Welcome pre-cal students to class on Tuesday, the 11th. I'm looking out the window, this snowy day today. Snow's coming down, so I guess we'll kind of see how the weather goes for the next couple of days here. Still fighting this cold thing a little bit, so a little raspy voice, but that will be a little annoying. I apologize, but we can deal with that. This Saturday you will have a quiz, so make sure you understand that and make sure you're ready for that. It must be turned in, completely done, all questions asked, no later than Tuesday. Remember, there's no class this Monday. I believe Hamilton County has that off for President's Day, I believe. So no video this Monday. We go with Hamilton County's schedule. No video this Monday. Number 3, your tests are due by Wednesday. Now, of course, snow might change that. In fact, it probably will. But as of now, work like it's due Wednesday, and then if you cannot get over and ask questions and turn it in, we can change that later. Excuse me, sorry. And then lastly, your integrity sheets. Please stay on top of those and make sure that you're good with those. All right. Well, let's go ahead and jump into this. Let me grab a quick drink of water and we'll get going here. We are going to go back now to chapter 1. Our goal was to review major Algebra 2 topics at first, and we did that. If you'll think back to what we did at first, we reviewed solving some equations, factoring, stuff like that, and so we did that. Next, our goal was then to cover 3 trig chapters. We did that. Next, I wanted to make sure that we covered series, sequences, permutations, combinations, and combinations, and probability. And we did that also. These were topics I wanted to make sure that we covered, and that is why we covered them first. Plus, I wanted to hit them while your brains were kind of fresh and new the first part of the year, and get some of the more difficult stuff out of the way. Now, don't misunderstand me. We're going to be doing some difficult math the whole year, but I wanted to get those main new topics out of the way. So let's go ahead and jump into chapter 1 and kind of see what happens here, okay? I think most of chapter 1 is going to be review and stuff that you've had before. Most of it. There'll be some new stuff, but most of it you've had before in the past. All right, let's go ahead and get started. Your heading today is called the Coordinate Plane and Linear Equations, Lesson 1.1, and the date today is the 11th. These topics should sound familiar, and if they don't, they will look familiar once we get into this. The Coordinate Plane and Linear Equations, Lesson 1.1, and the date today is the 11th. This is called the Cartesian coordinate plane. Take notes how you feel like you need to, guys, but this is called the Cartesian coordinate plane. You need to know that. The man that came up with this, his last name was Cartesian, and he is the one that came up with the Cartesian coordinate plane. All right? This axis here that goes vertical, up and down, is called your y-axis. Your y-axis. This axis here that goes left to right or horizontal is called your x-axis. Every year in the classes I teach, students get these two axes confused, and there's no need for that, okay? I always say to my students, and this might sound really, I don't know, dumb to you, but if it helps you remember it, do it, okay? I think of the y-axis points up to the sky, and y rhymes with sky, or you can say there's the letter y in the word sky, and this is pointing upward. I mean, whatever helps you remember it, you just can't get these two confused, okay? So the vertical axis is your y-axis, the horizontal axis is your x-axis. Sometimes these letters will change if you're doing a word problem. You might have a word problem in which you have distance based on speed or something like that, but the standard use of these two axes is the x and y axis. This point right here is called the origin, and it's right where the x and the y-axis intersect, and it's called the origin, or we also call it 0, 0, 0, 0. Okay, and that's this point right here. It's called the origin. You need to know that. All right, now remember, this is pretty much algebra 1 here. Now we're going to go through all these, we're going to start going through all these chapters now. And like I said, a lot of the stuff that you're going to get is review. The difference is we're going to go faster than you would normally go in an algebra class. We're going to cover a lot of topics today, and we will continue that throughout this chapter. And believe me, we're going to get into some new stuff. We're going to get into logarithms, systems. We're going to do a lot of stuff as the semester goes on. Okay, in your notes, let's go ahead and plot these ordered pairs. Whenever you're given an ordered pair, the first number is always your x number, and the second number is always your y number. So I'm going to plot the point 1, 4, and I'm going to call that letter A. So I go over 1 and up 4. There we go. Now let's plot negative 2, 5. Well, negative 2 means I go over 2, negative 2, and then positive 5 means I go up 5. Now, I'm teaching this, but I'm going fast. This really should be review, and I hope that it is. All right? All right, next ordered pair, negative 6, negative 3. So I go over 6. To the left, it's a negative 6, and then down 3, it's a negative 3. And we'll call that point C. Now, 2, negative 3. Well, that's a positive 2. And then down 3 right here, and we're going to call that point D. Then how about 0, negative 4? Now this first number is your x, so that means on the x-axis right here we go to 0. All right, so I go to 0, and then I go down negative 4. So there we go. This first number 0 meant that I did not go to the right and I did not go to the left. I stayed right in the middle, and I went down 4. And then this last ordered pair is 5, 0. Well, this is my x number right here. This is my y number, 0 is. So on the x-axis, I go to 5, 1, 2, 3, 4, 5. And then I don't go up any, and I don't go down any because my y is 0. So I stop right here, and I put a point. And we'll call that letter F. So there, what you just did is you just did something that's called plotting points, okay? All right, you plotted points. All right, let's continue on. Now let's go backwards. All right, so I'd like you to be able to tell me what some of these are. For example, this ordered pair right here, can you give me the name of that ordered pair? Well, you first of all put the x number. So on the x-axis, that point is over 1, 2, 3, 4. So I know that's going to be a negative 4. Comma, and then I went up 3, 1, 2, 3. That's a positive 3. So do you understand what we're doing now? We're going backwards. I want to give you ordered pairs, and you give me the names. Let's try this one here. All right. Well, this point here is over 2, 1, 2. That's a positive 2, and then it's up 1, 2, 3, 4, 5. So 2, comma 5. And how about this ordered pair right here? All right. Well, be careful on this one. The ones that fall right on the y or x-axis are a little confusing sometimes. Well, first of all, notice where this point is on the x-axis, the left and right movement. It's over 1, 2, 3, 4, 5, 6. I put a negative 6. And it's up none, and it's down none, so I put a 0, negative 6, 0. All right, let's try this ordered pair here. What would you call this ordered pair? Well, that ordered pair right there is called negative 3. And then it's down 4, so negative 4. So negative 3, negative 4. And let's try this ordered pair right here. All right, that ordered pair would be called, well, look at it. This ordered pair going left and right, it doesn't go left or right, it's right at 0. And then when you check out its up and down movement, it's up 2, so a positive 2. And then we'll go ahead and name this ordered pair right here. When you check this ordered pair's left-right movement, it's over to the right, 6. And when you check its up-down movement, it's down negative 2, or it's down 2, so negative 2. All right, so there we go. So we plotted points, and then I gave you points, and you gave me the name of those points. We call that naming ordered pairs. Let me get a drink here, and we'll continue on. Let's take a look now at linear equations. Linear equations. Here is an example of a linear equation. Please listen to me, Matthew, Caleb. Let me explain why it is called linear equation. Why it is called a linear equation is what I should have typed there. Notice the x has a power of 1 even though you can't see it. And notice the y has a power of 1 even though you can't see it. Whenever your variables have a power of 1, it is understood to be a linear equation. You do not need an x and a y to have a linear equation. This could be a linear equation. Your x has a power of 1. That's a linear equation. This could be a linear equation. Your a has a power of 1 and your b has a power of 1. I don't care what your coefficients are. It doesn't matter to me. I'm looking at your powers. Okay? So that is why we call these linear equations. Let's substitute in a couple of ordered pairs. And let's see if either one of these ordered pairs satisfy this linear equation. Okay? Let's substitute in a couple of ordered pairs and let's see if either one of these satisfy the linear equation. Let's try these two ordered pairs. Now watch what I do, okay? I'm going to take my equation, 2x plus 3y equals 18. And I'm going to take this ordered pair here and I'm going to substitute it into my linear equation, and I'm going to see if I get out a true or false statement. Now don't forget, this is your x and this is your y. So where the x is, I substitute a -5. Where my y is, I substitute a 7. 2 times -5 is -10. 3 times 7 is 21. -10 plus 21 would give you 11. 11 does not equal 18. So how would you answer this question? You would say this point is not a solution. It is not a solution for this linear equation right here. It is not. Okay? Now, in this class, now is that easy math? That's probably middle school. That's easy math, okay? But you need to be familiar with different phrases. From now on the rest of the year, when I say, hey, see if that ordered pair satisfies that equation, I need you to be able to substitute that ordered pair in and then check and see if it satisfies the equation, okay? All right, let's go ahead and I think I'm going to try 3 pairs on this one. We're going to try another one and then another one. All right, let's try 5, 0. So 2x plus 3y equals 18. Where the x is, I'm going to substitute a 5, and where the y is, I'm going to substitute a 0. Why those two numbers? Because I'm checking this ordered pair to see if it satisfies this equation. Well, 2 times 5 is 10. 3 times 0 is 0. 10 plus 0 is 10. 10 does not equal 18, so you would say no, this is not a solution. All right, let's try one more and then we'll go ahead and go on to something else. Let's try the ordered pair. Let's put a 3 in for x and a 4 in for y. All right, and let's see what happens. All right, where the x is, I'm going to substitute 3, and where the y is, I'm going to substitute 4. Now obviously I wanted to end with one that works, so that's what's going to happen here. 2 times 3 is 6. 3 times 4 is 12. 6 plus 12 is 18. 18 equals 18. So this ordered pair right here, you would say yes, it is a solution to this equation. By the way, there's more than one ordered pair that satisfies this equation. I can list a bunch of them out. One would be 0, 6. Another one would be 9, 0. Another one would be, let's see, 6, 2. I believe I did that in my head. I think that's right. But anyways, all of these ordered pairs here. You can, if you don't believe me, you can pause the video and test each one of these. You'll see each one of these satisfy this equation. I believe I did them in my head. I believe I'm right. But anyways, that is That is how you take an ordered pair and you check to see if it satisfies a linear equation, okay? So pretty simple stuff. Let's move on. Let me get a drink of water here. Finally, let's graph a couple of linear equations. We are going to graph each one two different ways. You are expected to be able to do both methods, okay? Both methods. Let's start off with this equation right here, 3x minus 5y equals negative 10, all right? Now here's the first thing I would like you to learn to do. First of all, students, on your paper, go ahead and draw a coordinate plane. You don't have to, you can have graphing paper, and I think that's awesome, but you don't have to. You can very quickly, man, I can draw a coordinate plane in about 30 seconds. And it's not the best, but it's pretty neat. I mean, just draw your tick marks. Going across here. Now that you've drawn your coordinate plane, which is really, like I said, pretty simple to do. I mean, it's not that hard. Now let's go ahead and let me show you a couple different ways to graph this. First of all, you can write a table of values. And let's just put some easy numbers in for x. I'm going to put in 0, 1, and 2. That's pretty easy. If you put a 0 in for x, look what you get. 3 times 0 minus 5y equals negative 10. Let me pause and say this. Mr. Earhart, this math is really easy and the video is pretty short. Guys, in case you don't realize it, in Algebra 1, we would have covered this in about 3 or 4 days. We're just quickly going over old stuff and also learning new stuff. Believe me, this we're going to cover tons of tough math, but I'm covering a lot of little topics each day. So if you find it easy, I'm happy for you, but it's not going to be like this all the time. Understand that, okay? Now I put a 0 in for x. 3 times 0 is 0. So I have 0 minus 5y equals a negative 10. And of course 0 minus 5y is just minus 5y. And then divide both sides by negative 5 and you will get out a 2. Y equals 2. Alright, so we're going to put a 2 into our table of values. And now let's put a 1 in for x. So 3 times 1 minus 5y equals a negative 10. 3 times 1 is 3 minus 5y equals a negative 10. Now bring the 3 over. When you bring it over, it becomes a negative 3. So you're then left with negative 5y equals negative 13 because you brought this 3 over and made it a negative 3. Okay? And then divide both sides by negative 5 and you should get a 2 3/5. That's approximately 2.6, I believe. Alright? And then let's erase that, and now let's put in 2. So 3 times 2 minus 5y equals negative 10. 3 times 2 is 6 minus 5y equals negative 10. And then bring your 6 over and make it a negative 6, and you would be left with negative 5y equals negative 16. Divide both sides by negative 5, and y equals 3 1/5, or 3.2. Okay, so with that in mind, let's go ahead and quickly plot these points and draw our line. Okay, and we'll see how we did. Your first ordered pair is 0, 2. That goes right there. Your next ordered pair is over 1 and up 2.6, so approximately there. And your other point is over 2 and up about 3.2. So there you go. Your 3 points should line up in a straight line. And you do draw a line that has arrows on both ends because the line continues on, and that should pretty much be a review. Okay, you should have done that before in the past, and that's how you graph a linear equation. We call that using the table of values method. Table of values. Okay, now I want to show you another method we're going to use now, and that method is called the double intercept method. Okay, the double intercept method. Okay guys, I'm back. I'm not sure what happened there. My computer totally froze up and the program shut down. So anyways, I'm back. Thankfully I didn't lose the video that I've made so far, but that was called the plotting or the table of values method. Now we're going to use a double intercept method. Double intercept method. And it's really easy. You put a 0 in for x, and then you put a 0 in for y. Let me say that again. Notice up top here, right here, I put a 0 in for x, and then notice down here I put a 0 in for y. That's how you find the x and y intercepts, or in other words, where the line crosses the x and y axes. Alright, let's start with this equation here. 3 times 0 is 0, and 0 minus 5y is negative 5y. See, it's a pretty quick method. And then divide both sides by negative 5, and y equals 2. Now you know what that tells me? That tells me to go to the y-axis and put a point at 2. So whenever you put a 0 in for x, you get out the y-intercept. Now I've put a 0 in for y. 5 times 0 is 0. 3x minus 0 is just 3x. Now divide both sides by 3, and x equals negative 3 1/3, or 3.3 repeating. So I go to the x-axis to negative 3 1/3, and I put a point there. So when I put a 0 in for y, it gave me out the x-intercept. Now that I know these 2 points, can I not very easily draw the line? Sure I can. And there you go. So you just learned 2 methods of graphing a linear equation. One is called the table of values method, and one is called the double intercept method. One more example and we'll be finished. Okay, so let me quickly, I'm going to move this coordinate plane to the next page so I don't have to make one. And then we'll go on to the next problem. Thanks for your patience, students. We'll put it right over here, and there we go. All right, now let's go ahead. You can work ahead or watch me. Let's go ahead and graph this linear equation 2 different ways. Let's use the table of values method, and let's use the double intercept method. Okay, let's go ahead and write our table of values here. Now, you can choose any x values you want. The only mandate that I have is you choose 3. Now, I'm going to use 0, 1, and 2. And you guys are pre-cal students, okay? Matthew, Caleb, I should have to do all this work for you. So I'm going to go ahead and you should be able to easily, my goodness, put a number in for x and get out a y. So I'm going to, this time, unlike the last problem, I did all the steps for you. This time I'm not going to. So if you put a 0 in for x and do all the work, trust me, sorry, my voice is really bad, you will get out a 4. If you put a 1 in for x, you would get a 2 times 1 is 2, bring it over, make it negative. Trust me, you will get out a 3 1/3, or 3.3 repeating. If you put a 2 in for x, you will get out 8 divided by 3. That would be 3 and, let's see, would that be 3 and, no, that would be 2 2/3, or 2.6 repeating. So go ahead and do the work if you want to, or you can just trust me. Either way is fine. But these are the 3 ordered pairs you'll get out. Now you might have chosen 3 different x values than I chose, but you still will get out the same line. Okay, 0, 4 goes right here. 1, 3 1/3 goes right here, and I messed up and I apologize, my fault. 0, 4 would go right here. I knew something wasn't right. 1 and 3 1/3 goes here, and then 2 and 2 2/3 would go just about right here. Notice they do line up in a straight line, which is what you want, even though I can't draw a straight line. And there we go. So you just graphed this linear equation using the what method? The table of values method, or the plotting points method, whatever you want to call it. Okay? All right, let's try now the double intercept method. Now, the double intercept method, as I showed you earlier, remember you put a 0 in for x, and then you put a 0 in for y. This is a really popular method. It's pretty fast. Now, if you put a 0 in for x and did all the work, you would get y equals 4. So from now on in the future, when I say, hey, Matthew, find the y-intercept, you immediately put 0 in for x. If I say, Caleb, find the x-intercept, you put 0 in for y. Okay? So y equals 4. There's my 1 intercept. That means the line passes through the y-axis at 4. And then over here, if I put 0 in for y, I will get out x equals 6. 1, 2, 3, 4, 5, 6 right here. And so that means the line's going to cross or pass through the x-axis at 6. So here's my line. Wow. Really hard to draw lines with this MimioPad, guys. Okay, now, look, that's the same line you had before. It is? Sure. Remember we were over 1, up 3 1/3. I mean, it's almost on the line. Then over 2, up 2 2/3. It's almost on the line. I mean, it's not going to be perfect because of fractions, and my line's not perfectly straight. But the other ordered pairs that we had in the last method fall right on that line. Okay, you get the same line. It doesn't matter what method you use, you get the exact same line. Okay, so that's it. Not a hard video, and I'm glad you get a little bit of a break when it comes to the really, really difficult stuff. Your assignment's pretty reasonable. This is 6 problems here, and this is 6 here, so you have a total of 12 of these to do. And I think that you'll find these pretty easy. Okay, all right, go ahead and get started at this time, and call or email if you have any questions.